Welcome back. I am Shankar Venkatagiri, your instructor for Statistics for Business 1. So we can say that Bermuda exhibits a lot more stable performance in its international tourism receipts than Latvia. Now let's focus on Bermuda. If we draw a line at the average receipts of $442 million, then we can claim that its yearly receipts do not deviate much from the average. Can we say the same for Latvia? So what I'm going to do is to calculate the mean receipts, and it's simply the average of D2 through S2, and I get that as my mean, whereas for Bermuda it's going to be slightly different. Now having done this, I'm going to look at the deviations from the mean. And how will I do this? I'm just going to say my first entry here is the same as the actual minus the mean, and each time, because I'm always looking up this cell over here, I'm going to put a dollar sign in there, and I notice that it's a negative number. This deviation can be negative. And all of those numbers towards the edge becomes positive. Now having calculated the mean and the deviations from the mean, I'm just going to go ahead and replicate these operations to Bermuda as well. And these are in fact the right amounts. 488 minus 442 is around 46, as you know. Now having done this, we realize, okay, the numbers are different. How about if we added up deviations for each country? So we will look at total deviations from the mean. And if I were to add up the deviations using the sum function, I need to add up D4 through S4. And I get a 0. Is it the same for Bermuda as well? Oh yes, they all total up to 0. So there's no way to distinguish between these two countries, right?
How about we take the absolute values of these deviations?
Absolutely, we will do that and then divide the sum of these absolute deviations by the number of years to get an average deviation. Now this is what is called mean absolute deviation, and it is in short form MAD.
I like that.
In Excel, there's even a function for this. It is avdev. So let's get back here. I have absolute deviations. I'm going to skip using the word mean. It is deviation from the mean. So I'm going to look at absolute value of this deviation over here and drag this all the way across to 2010. You notice that all of the numbers are positive and we have 16 of these numbers. Having done this, I'm going to look at the mean absolute deviation, and that is the average of deviations that belong to row number 6. So it is D6 through S6, and I get something like $300.6 million. I could do the same thing with Bermuda over here, and I get close to about $47 million. Now, if I calculated the average deviation, let me just take a look. I just need to look at the original set of numbers, which is in the second row, and calculate average deviation. So I have avdev of D2 through S2, and I get pretty much the same number. This tells us that Latvia's international tourism receipts are a lot more volatile than Bermuda's, and it's a quantitative answer, mind you. Starting with the same deviations, there's one more way to quantify variation. Instead of taking absolute values, we simply square the deviations.
And then calculate their average?
Yes, of course. I'm going to look at squared deviations. So this means that I'm simply going to square the deviation and do this right across from 1995 through 2010. These are my squared deviations, and if I were to average my squared deviations, and I get the average of whatever is in the 8th row as D8 through S8. I will now copy both of these rows onto Bermuda and I get a different average square deviation. So we need to have a number that talks about the annual variation. Therefore, we have averaged whatever we have gotten over 16 years.
But those are huge numbers.
Of course, these numbers are what are popularly called the statistical variance. Now we get the same answer with a neat spreadsheet function called var.p.
What's with the dot p?
Don't worry, for now we will say that p stands for population and the squared numbers that we are averaging over belongs to the population. Careful though, if we use the spreadsheet function called var without the dot p, then the denominator in our average turns out to be n minus 1, where n is 16 years of data. And that turns out to be a different answer.
That's a much higher figure.
So let's go ahead and calculate this variance directly with a spreadsheet function. So I will call this variance in this cell and I will calculate that by taking var.p of whatever is in D2 through S2. And I get pretty much the same numbers. Once again, we see that the variance of the receipts for Bermuda is orders of magnitude less than that for Latvia.
So many ways to talk about variation.
Yes, Lisa, there is one last measure of variation in a numerical data set, and that is standard deviation. It's simply the square root of the variance.
That what it is?
Yep, that's simple. So I have the square roots of the variance over here. I'm going to use the square root function and apply it to this number over here. I get about 348 or 350 if we were to round off for Latvia. For Bermuda, I get about 58 or round about 60. So that's 350 for Latvia and about 60 for Bermuda.
I like these numbers better.
Me too. By taking square roots of squared deviations, these numbers reflect simple deviations. In fact, they are called, you guessed it, standard deviations. What's more, we can express them using the same units as those of the original data. So in this segment, we showed you how to quantify the spread or dispersion of tourism receipts for a country. We compared Latvia and Bermuda, which appear to be similar along their means, but highly different along their spreads. I now leave it to you to carry out the same computations for the rest of the countries within our data set. You remember, we have to do the same thing to the final countries tab. I bet you will have a lot to talk about.
It's time I dispersed as well.
So see you again.